Okay, so graphing quadratic functions using the Vertex. So, lots of you had asked me last week or the week before, how do I graph these if I don't use decimals? Okay, so the only way we could do it at that point was to pick values for x, plug them in, get values for y. There is another way you can do that. It is still going to involve substitution, but this way, sometimes if you just choose, you end up choosing them all on one side and you can't really see what the parabola is doing. Okay, so we're going to try to do this. I know you don't have graph paper at home, but I guess really the skill is not necessarily drawing the graph, it's getting the point, because I am reasonably sure that if you knew what points to put on the graph, you could connect them with a curve. Okay, so let's see how. Okay, so the teak that this really goes under is A7A, which was the first teak we did when all this craziness started, the key attributes, and you had all those slides to do. Okay, so what we're going to do, that teak says you can graph quadratic functions, and then it talks about key attributes. So that's what we're going to do. We're going to use key attributes, like the axis of symmetry, the vertex, the y-intercept, to graph the functions, to sketch a graph, okay? So your learning targets then, based on that teak, are you can find the axis of symmetry using a quadratic function. So you're going to get the equation in these. It's not going to be something already graphed. Now, on a multiple choice test, like the EOC or semester exam, yes, of course, you can go to your calculator or go to decimals, graph the equation, and look and see where the axis of symmetry is. But for these, we're going to calculate it using the equation. Okay, and then you're going to use that to find the vertex, and then use the quadratic function to find the y-intercept. Okay, and then finally you're going to be able to graph the function using the key attributes. Okay, so those are your 3 learning targets. Keep those in mind. That's what you're supposed to get out of all of these notes. That's what you're going to be able to do by the time we're done. Here we go. I don't know if this takes long on your video, but it takes a while for it to load on my iPad here. All right, so our learning targets were, can you find the axis of symmetry with the quadratic function? Remember, there's a formula on your reference chart, opposite b over 2a. Okay, just plug in, evaluate, use a calculator if the negative sign is giving you trouble. Can you use the quadratic function then to find the intercept, the vertex, and the y-intercept? That's all about substitution. Put a 0 in for the x, that's how you're getting your y-intercept. The vertex, once you have your axis of symmetry, you have your x value, put that in for x. That's how you get the y value, your vertex. And then can you use those informations to graph, those pieces of information to graph your quadratic function? Can you find the y-intercept and plot it? Can you then find the vertex and plot it? Can you reflect a point and plot that and then draw them? And can you verify your answer is correct, justify, look for reasonableness by knowing, hey, this opens upward, that means I have a minimum point. Is that true on my graph? Is that what my graph looks like? This is positive, negative, so it opens downward, so I have a maximum point. Is that true when I look at my graph? Okay, all right, so make sure you have taking notes, or save this somewhere in your drive under algebra, or however you organize your drive, so that you have those steps and notes to follow. Okay, let me know if you have questions. Email, comment in the classroom, Google Chats. Okay, so let's review standard form. Y equals, or f of x equals, ax squared plus bx plus c. And remember, a cannot be 0. If a is 0, you don't have an x squared term anymore, and now you have a linear function. Okay, b can be 0, c can be 0, a cannot be 0. Alrighty, so we are going to graph the quadratic function. To do that, like to graph a line, you need 2 points. To graph a parabola, you need a minimum of 3 points. The more points you have, the easier it will be generally, but you need at least 3 so that you can kind of see where that parabola is going. You need to make sure you're able to see that vertex, that maximum or minimum. You need to know when the parabola is going to turn around. You need to know whether it's going to be concave up or concave down. Okay, we're going to use the function to find these key attributes, and we're going to look for the y-intercept, the axis of symmetry, and the vertex. Okay, so here we have our handy-dandy reference chart, and as luck would have it, right here, look, it gives us a formula for axis of symmetry. You don't have to memorize it. Lucky people. And also, notice here is standard form right there in case you forget. Okay? All right, so the axis of symmetry, it will give us the x-coordinate. Look, it says x equals. And we have an A and a B, which are right here in your standard form. There's an A, there's a B, there we go. Okay, so that's all we're going to do is basically substitute, evaluate, and then we'll do something with that. So, see, I have here a little piece of graph paper. Oh, it didn't show up. I wasn't sure if that was going to work. Okay, so sorry, I was thinking I should probably did an example about how to find the axis of symmetry, but here are some steps. So if you are not taking notes, pause, go get a journal, a piece of paper, or open a spreadsheet. I keep saying I will share these with you guys, and I think I keep forgetting to do that in case you want like my original slideshow that I started with, and you can keep that for notes or take notes on it. So if you're like, yeah, I thought you were going to send me that and I didn't, let me know and I will send that to you. So here we have 3 steps, and basically it doesn't matter what order you really do these steps in. The first thing I put down for step 1 is find the y-intercept, because we've been doing that for a long time. We could find the y-intercept in linear functions. You know the y-intercept is where x equals 0. So put a 0 in for x. That's going to make the ax squared term go away, because 0 squared is 0. Anything multiplied by 0 is 0. It's going to make the bx term go away, because again, anything times 0 is 0. So basically, if your equation is written in standard form, then c is going to be your y-intercept. So you're going to plot that y-intercept. Step 2, now here's the new stuff. We're going to find the axis of symmetry, and then we're going to substitute that x value in the function to get the y value of the vertex. You're going to plot the vertex. Okay, so right now, I just feel weird. I haven't written anything. Oh my. So here's my coordinate grid. So right now I have a y-intercept. Maybe it's here. Okay. I do this. I get, let's just say my y-intercept was, I'm making it up. Okay, 0, 2. And maybe I do this. I get 1 for my, let's say it's a minimum point. And then I substitute that 1 back into my equation, and I get, say, -2. Okay, so 1, -2 here. So there's my vertex. So I know my parabola is going to come down here, and at this point it's going to head back this way. But I don't know how thick it's going to be. So that's why we need a step 3. So there are 2 ways you can do this, and I looked through some old notes, and I think I probably got them right out of the book a couple years ago, and it said basically this, but I'm like, why? We already have the y-intercept. Now, the only thing is, if your y-intercept is also your vertex, you're going to need to choose some other points. And maybe that'll come up in one of the examples. If not, I will think about what example that would happen in and let you know. Okay, so the axis of symmetry would be, in this case, x equals 1. So that goes right through your vertex. So if this y-intercept is 1 unit away here, I go 1 unit away over here. And so I will plot the point 2, 2. And now I know my parabola is going to be about that wide. Okay, so depending on how far apart these are, if they're really close, it might be hard to draw a really nice parabola. But honestly, if I'm grading, if we were in school as normal and I was grading your graphs, I'm checking, did you plot the y-intercept correctly? Did you plot the vertex correctly? Did you get another point? And that's what I would be checking, not how pretty your parabola looks. Okay. All right, so if you want another one, a smoother curve, you just pick another point. So maybe I'm going to pick, well, I have 0, I have 1, maybe I'm going to pick like 3, come over here, see where it is, reflect it over the axis of symmetry, okay? All right, so those are your steps. Find the y-intercept, that's 1 point. Step 2, find the vertex, that's the 2nd point. Step 3, either find another point or reflect your y-intercept. Now, like I said, if your vertex is your y-intercept, you're going to need to find another point that you need to reflect. And it just pick whatever works for you for x. Okay, all right, have now, yes, examples. Okay, so here's where we're going to see if we can add some slides and get some graph paper going. All right, so step 1, let's find the y-intercept. And that's where x equals 0. So if I put a 0 in, and instead of, see that says f of x, it's just a y. So I'm going to go ahead and change it to a y because I'm going to plot x, y coordinates, right? So y will equal 0 squared minus 6 times 0 plus 4. So you see y equals 4. So the first point I am going to plot is 0, 4. Okay. So let me add a page. My y-intercept was 0. Back here, the next step said to find my axis of symmetry. I want to find that because that's going to give me my x-coordinate of my vertex. Remember, the axis of symmetry goes right through the vertex. The vertex is on the axis of symmetry. So if you find your vertex, you already have your axis of symmetry. It's x equals whatever that x-coordinate is. So this way, we're kind of going backwards. We're going to find what the x-coordinate is. Okay, so I look on my reference chart and I see that x is equal to opposite of b divided by 2 times a. Okay, so let me scooch this up a little bit. It might be a good idea to write down over here, my a is 1, my b is negative 6, my c is 4. So that might be a good thing to have, you know, on hand. Sorry. Okay, so I wanted to go over that in case you, I don't know if the green's going to show up. You never know, sometimes it does. Okay, so x equals opposite b. I'm going to write this down a little lower off that corkboard so you can see. Opposite of b, well, b is negative 6, so I'm going to write it like that. You're welcome to do that in your head if you want. Opposite of negative 6 is positive 6. 2 times 1 is 2, so that's 3. So my x-coordinate is 3. So far, I know that my vertex is 3, something. How am I going to find my y? Well, here we have an equation that says y equals, so that's what I'm going to use. So if y equals x squared minus 6x plus 4, and I know that x is 3, I'm going to go put a 3 in for x to figure out what y is. So 3 squared minus 6 times 3 plus 4. 3 times 3 is 9, negative 6 times 3 is 18, plus 4. And 9 minus 18 is negative 9. Negative 9 plus 4 is negative 5. So that's the y-coordinate of my vertex. So I'm going to go plot that point on my graph. 3, negative 5. Back and I look at my equation. My a is positive. So that means this is going to open upward. It's going to be concave up. So I know the general shape of my parabola is going to do that. Okay, so there's one hint. Okay, step 3 said to basically get another point. So we could reflect the y-intercept over the axis of symmetry, Or we could find another point and then reflect that point over the x-intercept. Okay, so let me go here and see if I can add. I put a picture on the drive of graph paper because I think that will work the best. So let's see. Oh yes, that's beautiful. Oh, there it goes. Okay, I thought it was going to be all pixelated. Okay, yay. All right, so let me go back. 04. Let them use. Oh, you know what? I will use purple. Maybe it doesn't matter. Okay, I'm sorry. This does not need to take this long. Oh. Okay, blue it is. Okay, so 0, 1, 2, 3, 4. Let me see if I can make this graph paper a little bigger. There we go. 1, 2, 3, 1, 2, 3, 4. Okay, so there's my y-intercept, 0, 4. Okay, all right. So 1, 2, 3, 1, 2, 3, 4, 5. 3, -5 right here. Okay, so right now, I could draw several different parabolas. I could have one that opens up. I could have one that opens down. I could have a wide one and a narrow one. So I need another point. Okay, so if I graph, and I'm going to dot in here my axis of symmetry, which is right here. That's my axis of symmetry. Okay, why do I care about that? Is because I know it's symmetrical. So if the y-intercept is 3 units from the axis of symmetry, then I know there's another point 3 units on the other side of this. So I'm just going to reflect that over, and there's my point. Okay, now if I try to draw this, it's going to be very V-shaped. So I'm going to show you what I mean by pick another point. Okay, so I'm going to pick this point here. X is 1. Okay, so actually I'm not going to pick that point. I'm just going to pick the value. So I'm going to choose, just because I feel like choosing x equals 1. I think 1 will be pretty easy to work with. Choose x equals 1, and then I'm going to see what y equals. Well, I'm going to write down my equation again, minus 6x plus 4. So if I'm saying x is 1, I'm going to put a 1 in for x and solve for y. 1 squared is 1, 6 times 1, -6, plus 4. 1 minus 6 is -5, plus 4. Y equals -1. So my other point I'm going to plot is 1, -1. That is a point on that parabola. How do I know that? Because it makes that equation true. That's like a huge thing no matter what kind of function you have. If you have a linear equation, quadratic equation, or whatever, any point that makes the equation true is on that graph. It's on that line. It's on that parabola. It's on whatever kind of crazy graph you have. Okay? So 1, -1 is here. So if 1, -1 is there, and there's another point just like it on the other side of the axis of symmetry. So 2 units away, I go 2 units away. There's the reflected point. Okay? And now I'm going to try to draw my parabola. I will use the green, see how that works. So there we go. That's not too bad. Just try to get as many points as you can. Okay? Okay, so let's look at some more examples. So I'm going to go plot that. I put quite a few of them in here because I know examples. Okay, so we're graphing this equation. Okay? So I'm going to first start by finding my y-intercept, only because I think that's the easy thing to start with. Well, easier at any rate. No, I said the E word. We're not supposed to say the E word. Okay. Y-intercept. So my y-intercept is when x equals 0, So I'm going to go ahead and put a 0 in for all of these x's. And as you know, they're going to, that's 0, so 9. Now, if you're saying, why do I need to go through this? I already know that that's going to be my y-intercept. Okay, that's fine. But in case you didn't, now you know why it's 9. Okay? And I said before, and I forget to do this, but it is helpful in this unit. It's going to be helpful in the next one as well. Next topic for this. If you write down what A, B, and C are, because you're going to be using those. So A is -2, B is 8, and C is 9. And like I said, if your equation is in standard form, then yes, C would be your y-intercept. Okay. All right, so that's my y-intercept. So let me go get, okay, I'm going to go back here. So I have all my problems, my numbers here rather. Number 2, the axis of symmetry. Okay, so I look on my reference chart, I write down my formula, opposite B over 2A. I write that down every single time. And I will tell you, I say that to you guys, I say that to Math 8, I say that to Math 7. Anytime there's a formula to be used, I write it down. I write it down. Okay, back in my day, we didn't have a reference chart. I had to memorize all that anyway, and I still write it down every single time because it just helps you stay organized. And, you know, you guys know, as you see, as I'm working, sometimes I'm a messy math person, and then I'm not organized, and then I make mistakes. Okay, so, all right, so X, oops, don't have a pen. There we go. So X is opposite of B, and B is 8, times a product, or over divided by 2 times A. So A is -2, so 2 times -2. Okay, so -8 over -4, so X equals 2. So remember, that is my X coordinate of my vertex. It's my axis of symmetry. So let's go to the graph and see if we can kind of make a little bit of a guess here. Is our vertex going to be a maximum or a minimum? Ooh, that's a good question if I put this into Edpuzzle. So I'll pause a moment. Okay, so maximum or minimum. So that means, is this going to be concave up or concave down? Which means, does my parabola open up like a U, or does it open down like a frown? Okay, so, yeah. So, A is negative. That means it's going to be concave down. So that means I'm going to have a maximum point. So that means I'm going to have to move my graph paper down a little bit to see where that maximum point is. Okay, so let's see if we figure that out. I'm going to give myself some room here, because the second part of this step 2 is to find the y-coordinate. Well, I know that y is equal to -2. Hang on, let me write that in black so it doesn't all run together. I know from my problem that y is equal to -2x squared plus 8x plus 9. And I know that x is 2, so I'm going to put a 2 in every time I see an x. There's another x. That's 2. Why? Because we just said it was up there. Okay, so I took my 2, x equals 2, and I put a 2 in for every x here. Okay? Oh, that's weird. It doesn't all connect. Alrighty. Okay, so y equals -2 times 4 plus 16 plus 9, -8 plus 16 plus 9, -8 plus 16, -8 plus 9, so y equals 1. Okay, so that's the ordered pair I'm going to graph for my vertex. It is at 2, 1. This isn't making sense. Hang on, let me go see. Hello. Negative 8 plus 16 is positive 8. Oops, see, this is why you need to look and kind of think about what is this really going to look like, because this happens. Oh my goodness. And it happens I can't make a plus sign. I don't know why. There. Okay, so this is really 17, and yes, I remember this problem because the graph I gave, put on the paper, this came from an old worksheet. You couldn't get to 17, so you had to scale it. It was a big old mess. Okay, so never mind. This is 2, 17. Now that makes sense. Another piece of graph paper here. Okay, so let me bring it in closer. I have to sneeze. Hang on a second. All right, so 0, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's my y-intercept. Okay, in right now. So x equals 2. That's my axis of symmetry. I'm going to go, I like to do a dotted line for the axis of symmetry. I guess it doesn't really matter what you do. Okay, so I know that I have another point there on the other side. I can reflect that. You can do it right now if you want. And then all you have to do is figure out where this vertex is going to be. So let's go back to our comma 1 is my vertex. That's here. That does not make sense to me because my y-intercept is at 9. And my A is negative, so it definitely should open down. Oh, I know what I did wrong. Because it does open down. So I don't know if I can undo this. Yes, I can. Okay. So I'm going to need to move my graph paper down here. And we'll see if I have enough room to plot this. So 2, 17. So 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, I'll put a 17 there, and we can put a 9 here. Just in case you're trying to follow along, you can't see those little grids. Okay, so now this makes sense because that's clearly a maximum. Step 3 says to get a third point, I can just reflect this over the axis of symmetry. So it's 2 units away. I go 2 on the other side, and that's my reflected point. Okay, and now I can draw. If you're like, yeah, it's like I don't know where that's going, what you can do is pick x equals 1 and see what happens, or you could even like pick x equals -2, but I'm not sure I'm going to have enough room. All right, I'm going to attempt to draw this. It's not going to be real smooth. Do not make it be like this. That's another function entirely. Okay, so I know sometimes it's hard to get it to curve and it looks like pointy. Sorry, we want u's, not v's. V's are another type of function that you will probably learn next year. I think Algebra 2, you'll deal with that. If not that, then in pre-cal. Okay, so if you wanted to pick another value for x, say I wanted to say x equals 1. So then in my equation, -2x squared plus 8x plus 9, I think. So now I'm just going to put a 1 in for the x. So -2 times 1, -2 plus 8 plus 9 plus 8 plus 9, 6 plus 9, 15. So 1, 9, 10, 11, 12, 13, 14, 15. Oops. I'll go there. I don't know what I hit. Hopefully I didn't mess up our recording. And there, and you see that might make it easier to make it smoother, okay? But, you know, I do my best. Okay, here's another example. So f of x equals 2x squared minus 5x. So a is 2, b is -5. Uh-oh, what is c? C is not here. What number do we use when we have nothing, when it's not there? 0. Okay. All right, so let's see how this works. So step 1 says find the y-intercept. Well, the y-intercept here is going to be 0, 0. So this might be, I wanted to add a page. Next step was to find the axis of symmetry. And that's x equals opposite b over 2a. So x equals the opposite of negative 5 over 2 times a is 2. Okay, so x equals opposite of negative 5 is positive 5, and 2 times 2 is 4. Oh, well, this is what happens when you just pick random numbers and you don't think about what this is going to look like. All right, so 5/4 is my axis of symmetry. So I'm going to probably make my scale go by fourths. All right, let's see what our y is. All right, so if x is 5/4, and you can make that 1.25 if you want, I'm going to leave it 5/4 and just see how far we get. So y equals 2x squared minus 5x. So y equals 2 times x is 5/4. Oh, I thought I had blue there. 5/4. Oh, yay, we get to square that. Super fun. This is why I stopped making up problems years ago, and I just usually go to the book. Why I didn't go open the book to see? I just wanted to make sure there was one with no C. Yeah, I don't know. I don't feel well today. So there you go. That's my excuse. 25/16 minus 25/4. Okay, well, that can be simplified. So y equals 25/8 minus 25/4. I need common denominators. And like I said, if you guys use decimals, it's fine. Because what I don't want is 72 questions about how to do fractions. Fractions is like 5th grade, guys, 6th grade. So just use a calculator. Don't worry about it. These are fourths and eighths. So they should terminate. If they don't, just round it. This is all going to be kind of, close anyway. All right, so I gotta get common denominators, which you learned way back in the day. So times 2 is 8, so times 2 is 50. So, quite conveniently, my y is going to be, let's see, negative 25/8. Awesome. Okay, so I'm going to attempt to plot the point 5/4, negative 25/8. So I think I might make that fourths, because I really think I'm still going to go with fourths. And half of 25 is 12.5. All right, let's go see what we can do. A is positive. I'll go back up so you can see A is positive. So it is going to open upward. We want to add another graph. Graph paper. Done. Okay, so 0, 0 is my y-intercept. Well, there is an issue here. I'm not going to be able to reflect that. I don't think very well. Well, maybe. I don't know. Let's see. Okay. All right. So if I go by fourths, 1, 2, 3, that makes that 1. 1, 2, 3, 4, and that 2. And so that's going to be, I think I just go by ones on the y, because I'm not going to have enough room. So 5/4 is here. So I know my axis of symmetry is right here. And I kind of do want that to be pretty accurate. Okay, the y value was negative 25 eighths, and 8 goes into 25 3 times. So 3 1/8, so that's pretty close to 3. So I'm just going to go, I know it's negative 2. Maybe I'll go halves. So that's negative 1, negative 2, negative 3, negative 4. Yeah, it's going to be pretty close. Just be like right there. Not halfway, pretty close to negative 3. Okay. Alrighty, so then if I look at my equation, appears to be what's going on. That's my axis of symmetry. I can reflect this point. It's 1, 2, 3, 4, 5 units, or 1 1/4 units away. So over here I need to go 1, 2, 3, 4, 5 units. And that's what my parabola looks like. Ah. Beautiful. Not really, but there you go. Okay. Alrighty. Let's see. Nope. Last example. Okay, this one will work. It's like I made this one up too. What's different about this one? So what do you notice about this one? So let me just pause a second because I'll ask you that question. What do you notice about this equation? How is it different? How is it alike from the standard form? Okay, yeah, there's no b term. So here we have no b term. A is negative 1. At least I think this is going to work. I should have made that positive 1. Okay, B is 0, and C is negative 9. This is almost the difference of 2 squares. If you remember, we were talking about that right before we left for spring break, except for negative x squared is not a perfect square, but x squared is, and 9 is, but that's okay. All right, so number 1, find the y-intercept. Well, the y-intercept is going to be negative 9, because the opposite of 0 squared is still 0. 0 minus 9, negative 9. Okay, so let's go. Moving on. Let's find the axis of symmetry. So x, arrow rather. Oh my goodness, that's a mess. So sorry. X equals opposite b over 2a. So x equals opposite b, negative 0, over 2 times negative 1, it's 0, right? Because there is no, if 0 is in the numerator, anything divided by 0 is 0. Okay, so here's what's going to happen. So if x is 0, guess what this means? If x is 0, then y is negative 9, because it's the y-intercept. So in this case, this is what I was talking about, and I'm glad I remembered to include you an example. The vertex is the y-intercept, so you can't, they're not 2 different points. And remember, we needed 3 points. So let's go graph paper in here, and we will plot that one. Okay, let me bring it closer, and it was 0, negative 9. There we go. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so far so good. In our axis of symmetry at here, the y-axis, and so this is also our vertex. It's our vertex, and it's our y-intercept. Okay, no problem. We just have to pick another point and reflect it. So because I want like a nice looking parabola, and let me think about this, my A is negative, so this is going to open down. So I'm going to scooch my graph up here. I don't want to pick x equals 1, because if I pick x equals 1, it's going to be like right close here. So I'm going to go x equals 3. So I'm picking that just out of the blue. I decide I want to use x equals 3, and I'm going to get another point on this side here, of the axis of symmetry, so then I can reflect it, and there's my 3 points. All right, so my equation is y equals negative x squared minus 9. So I'm choosing 3. So the opposite of 3 squared. Oh, so sorry. 3, that should be black, squared minus 9. So here's where you need to be careful, and we talked about this a couple of times this year. That negative sign is outside of like a parenthesis. Okay, so it's not negative 3 squared, it's the opposite of 3 squared, because x is 3. So 3 squared is 9, so negative 9 minus 9, so this is going to give us negative 18, and I'm not sure I'm going to have enough room. 10, 11, 12, 13, 14, 15, 16, 17. Oh yeah, I do. Okay. So that means I'm going to plot this point, 3 comma negative 18. That point is nothing. It's just a point on the parabola. It's not the vertex. It's not an axis of symmetry. It's not a y-intercept. It's not an x-intercept. It's just some random point on that parabola. Okay, so 3, there's negative 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, and now I'm going to reflect it over the axis of symmetry. So since I'm 3 units away here, I need to be 1, 2, 3 units away here. Okay, because if I put a negative 3 in here, watch, negative 3, I'm going to get the same answer. Okay, because negative 3 times negative 3 is positive 9. It's the opposite, etc. Okay, and so now I can theoretically draw a parabola through these. And it's, I mean, I'm not much better on paper, but it's a little bit hard on here. Okay, so there you go. Okay, so again, find your y-intercept, do your axis of symmetry. If that's a different, to find your vertex. If those are 2 different points, you're all set. Reflect your y-intercept, call it a day, draw your parabola. If they're the same, you have to do what we just did here. You need to choose another point on one side of that axis of symmetry, and it doesn't matter which one you choose. Okay? All right. Yeah, I thought I had been distracted. I wanted to put in another slide about your learning targets. So let's go back and review your learning targets here. Let me go back and find the learning target slide for you, and we'll see how you think you did.